the inspection and installation of piston rings and the piston assembly into the block. So taking a look at this particular piston here, it's already been installed in the correct position on the rod, facing where it should be based on the manufacturer's recommendation. A couple different things we have to take a look at here is, one, this top ring groove, which is called a keystone groove or a trapezoidal angle, which means that we have two equal sides and two unequal sides to give us that trapezoidal design. The purpose behind that ring groove and the ring being used like that is to provide better pressure to be able to push the ring out onto the cylinder wall, as well as provides more longevity for the customer in the engine. Now the top ring here, this is an aluminum trunk style piston, semi-floating, and the pin also rotates in here, in the small end of the connecting rod. We have what's called a nye band insert or a nickel band insert. Nickel tends to provide a lot of wearability as well as longevity for this particular piston. If we had a standard aluminum groove, the piston would wear out very, very quickly. So the trapezoidal ring design also helps provide better and even pressure moving out against the cylinder wall to provide better sealing. Provides lots of longevity, and again with the nickel insert, and this way the two of them together marry. Now this here, when we have a nickel insert, the compression ring itself becomes a sacrificial wear component as opposed to the nickel insert. So a lot of times the piston still falls within specification after inspection, but the rings fall out of specification. So if we take a look at a different style of tool than the one for this particular engine, this one's for a Series 60 Detroit engine. And looking at the tool, this is called a keystone gauge or a piston ring groove gauge. You can see on this diagram that the keystone gauge has to fit into it but not allow for the edges to touch. Here and here. If they were to bottom in the groove, that indicates the groove is worn, and subsequently so would the piston ring be worn. So at the point of service, the mechanic would use the keystone gauge or the ring groove gauge to determine, is the ring sufficient to put new rings back onto or to just to put back into service. Cummins also provides keystone groove wear gauges with particular part numbers based on reference from the service manual. And it shows right on the back exactly which grooves you can test based on the keystone configuration of the piston, and the sizes according to what the manufacturer is looking for that inspection. It also tells us how to check it and gives us a descriptor on how to insert the gauge and check it correctly. And again, you can see these keystone gauges have that trapezoidal anvil on the gauge, as well as numbers supporting the measurement and the position of where the gauge is checked or used to check the wear on the piston ring grooves. The manufacturer of this particular piston, which is an international engine, uses this particular style of tool. And this tool, again, is right out of the service manual. And how we check this is we install this gauge into the grooves. And it can be turned and inspected all the way around the piston. And what we're looking for here, right here, is to make sure that this gauge guide does not drop below the outer surfaces of that trapezoidal ring groove. Just like we would be checking with the ring groove gauge, we want to make sure that the edges don't butt down. If they do, they're sinking too far into the groove, which supports the groove being worn and the piston for replacement. This one being a brand new piston, For the instruction purpose, we can see that we've got lots of material sticking up above the groove, which supports a brand new piston, as well as being able to put the brand new ring into that particular piston. The oil control ring assembly. We call it an assembly because it's more than one component. We have the outer scraper, which has two sharp edges on it. There's oil relief holes all the way around the circumference of the ring. We also have the inner control ring, which helps hold oil and then allow it to return back through these oil return channels. Some different engine manufacturers use holes to control how quickly the oil gets back after it's scraped off with the scraper. Okay, so when the scraper goes up and down in the cylinder, it provides enough lubrication to help seal it to the cylinder wall and reduce friction, as well as coming back down, it scrapes off the excess. The excess then goes into these return grooves, flood the inner oil control ring, and then excess dumps out of the oil return channels or holes, depending on the manufactured piston design. So this assembly, when it's put together, and we always put them together with parting lines on the opposite side. So taking a look at this manufacturer's ring set, this is a Cummins ring set. And this particular manufacturer uses color designation for the parting line to make sure it's correctly oriented once it's installed onto the piston. So this was what we call the circumferential oil control assembly. So we have the scraper and the circumferential ring that goes on the inside. If we take a look at the pink designation here, directly 180 degrees apart from it, we should have the parting line. And what the manufacturer wants to do is when it's assembled, pink to pink, that we should have the parting lines pretty well 180 degrees apart. We don't want to ever line these up, because as this ring is opening and closing during operation, it could actually end bind with this circumferential ring and causing a problem for fit as well as friction increase. So this ring assembly, very similar to the Cummins one, we have the scraper plus we have the circumferential ring. We want to install this onto the piston. Noting the position of the parting line. And I'm going to use the pin boss as a guide for where it is. We're going to use this style of ring expanding plier because this style here holds lots of radial pressure around the outside of the ring so that we don't overstretch the ring or damage the ring. So my parting line is at the piston pin boss, and now I'm going to open this ring up just large enough to get over the top of the piston and the ring. So dropping it into the groove. And confirming the fit. Now we have that assembly together and the parting line is opposite. So that's the oil control ring assembly. The next one we take a look at is the second ring. And again, it's a trapezoidal design, but it's in a groove that does not have a nickel insert. The nickel insert is for the high pressure on the very top of the piston. This one works in combination capacity to help seal the top one and to help reduce some of the oil that's coming off and being controlled by the oil control ring. So we will install the second ring, pushing it up into the groove and releasing the tension. Now, one of the biggest things that comes to question for me is, can we just spiral these rings into position? It's never recommended that you ever spiral a ring, because if you do, you can actually twist the configuration of the ring, not allowing it to move correctly in the bore. Now, these rings will move slightly back and forth, but they do not do laps. Okay? If they did, then the problem would be is that the grooves would line up, allowing excessive blow-by, and then no compression pressure or ratio in that particular cylinder. So we're going to install the last ring. One of the things that we have to take a look at is for the position of the ring is, do we have an indicator mark? This particular manufacturer uses one dot to tell you that that faces up and it's the first ring. If the second ring has no indications on it, then that's the position for that ring. You can't mix up the oil in the secondary, but you could mix up the secondary and the primary ring. So this manufacturer has taken out the guesswork and put one dot indicating up and the position as first ring. So we'll go ahead and install this ring now in the correct position. Pushing it into the groove and releasing it. So we can see now that all the piston rings sit on here, they're free to turn, there's nothing binding it. The next thing we want to do is just take some engine oil, typically crankcase oil will support that. Make sure your hands are clean. And when we go to install this piston, it always goes together wet. Everything has to be wet when it's assembled in the engine because that's how the engine operates. It always has oil in there. There's oil being put on the walls of the cylinder as well as being taken off at a controlled rate by the ring assemblies. So what we want to do is when we're lubricating this piston prior to installing it in the engine, we want to flood the rings. Okay, and I'm going to flood the entire piston because I don't want any friction when I go to install. Lots of oil is good. So I'm lifting it, it allows the oil to go into the channels, I can spin the rings, they move nice and freely, okay, and this way I know that it's going to start up wet. Well, next thing we want to do is to establish the ring stagger. Some manufacturers give you guidelines that they would like the rings to be staggered 90 degrees to 120 degrees apart. One thing that we'd never do is start our parting line directly in the center of the pin boss because compression pressure can leak down through here, through the hole and down into the bottom end. So what we're going to do in this particular case is offset it to about that position, and we're going to go 90 degrees is what the manufacturer prescribes on this one, which would be about there, and then 90 degrees from that ring with the primary ring, which is about there. Different style of piston ring compressors. Now we have the piston all ready to go into the engine block, the bore of the engine, and we're going to take a look at different style of piston ring compressors. This one happens to be a Kent Moore tool for a Series 60 Detroit, and they call that a tapered sleeve. What that does is it allows a tapered angle like this so that when we take the piston and start to push it down into the bore, the piston skirt aligns it into the bore, and then when you tap on the piston or push it slowly, it causes the rings to move up into the taper, causing the rings to compress equally and evenly until it's installed into the cylinder. A different style that can be used is the band style ring compressor. So we have a tool where we can release. With an Allen key we can release the tension and then we can wind it up as need be. So we can take a look at the function of this ring compressor and then we can release it and adjust it out or in under tension. So if we're using this style, we would wind it down onto the piston just at about this particular height and using the piston trunk to guide us into the bore, like you'll see during the install with this particular piston. Another style is the cast band style. These are made for OEM applications where we would install this around the piston, lock the pin, then we could take the whole assembly and by hand drop it into the bore in the engine. They're a little more expensive than the previous styles that you've seen, but they have a lot of longevity as well as specific types and styles of sizes that are available for different engines. Another style is the band style. And again, it's an adjustable one that we can use. We can maintain a small amount of tension on here to increase or decrease the tension around the trunk of the piston. So now that we know that the ring stagger is correct based on positioning by the manufacturer, we need to lubricate this ring compressor. Okay, so now taking the band clamp and going around the piston rings, knowing the position that I'd like it to sit in, and I want to cover all of the rings. I'm just going to push my hand on this side and then close the ring compressor. And when I close that compressor, I'm just going to put some movement on it so I know that I'm not binding against the rings. And once it's installed, I should be able to move it, which indicates that the compression of the rings was done correctly and there's no binding or fracturing of the rings.